Hello and good day, everyone. Today, we would like to share and discuss our opinion about the Biological Diversity Assessment ENT3322. Before we start our discussion, I want to introduce our panel today. Before that, my name is Ronly Ronald Josta as a moderator for today, and our panel is Aslan bin Kanu, Bavatarani anak perempuan Chandran, Izzat Syazani bin Muhammad Barakat Ali, Muhammad Fahmi Amin bin Roslan, Muhammad Fikri bin Muhammad Kone, Muhammad Shahir bin Zulkifli, Nur Afika Amira binti Ismail, and Nur Fatiha binti Mustafa. Alright, based on the data of plots given in the Excel sheet, we will discuss and identify a few important of the result. Now, I would like to invite, no, I'm sorry for that. The data of plot in the Excel sheet given show that there is 947 species are found in total of 4 plots. After sorting the data with the same species in total is 95 species. The highest frequency number of species is Kalat, which is 126 individuals in total, while the lowest frequency number of species, which is from total 10 to 1 frequency, have 61 species. However, from the data, the most lowest frequency number of species in total that count 1 is Dedali, Karas, Geranji, Bulu, Ludai Melunai, Mengkulai Jari, Meranti Paang, Merbatu, Merpau, Nyatu Taban Putih, Simpo, Tempinis, Terentang Simpo, and Tualang, which is the overall of the total is 14 species. Now, I would like to invite Aslan to share about his opinion on data that can calculate based on DBH. Okay, Aslan, the floor is yours. Aslan, don't forget to open your mic.
Sorry. Thank you, Ron. Okay. Firstly, DBH is typically referred to diameter at breast height, which is a standard measurement of the diameter of the tree trunk at the specific height, typically 1.3 meters above the ground. So, that you can calculate based on the DBH are tree age estimation, biomass estimation, carbon sequestration, stand density, and basal area. At the last, tree grow rates. Okay, for the data, the highest DBH is 191.9 cm. This is a growing species. The lowest DBH is 1 centimeter. For the species is Kekatong and Pulasan. So that's all for me.
Thanks, Aslan, for the information. Next, I would like to invite Shahir and Izzat that will share about the basal area. Okay.
Thank you to moderator. I will describe the basal area. The basal area is the cross-sectional measurement of the tree measured at chest height, diameter 1.3 meters from the ground surface. Basal area is usually measured in units of area such as square centimeter or square feet. Total base area for all the tree is 724853.7 square centimeter. Basal area estimation is for forest density and structure. Basal area provide a measure of how density trees are distributed in the forest. Basal area is important parameter used in forest management. Next is important value index. In important value index, you must have a relative frequency, relative dominance, relative abundance. For relative frequency is to show species found in percentage at the total area, which is the total sum species in the area or plot. Relative density is to show the density of the species of some area. And last, relative dominance is to show the some species is dominant in that area. And we get the important value index. Important value index is how you to measure the dominance of species in some area. Next, we'll pass to Izzat Shazani.
Thank you, Shahid and moderator. So next is above ground biomass. So above ground biomass refer to the total weight of living plant material present above the soil surface in a particular area, typically measured in terms of dry weight per unit area. This includes stem, leaf, branches, and any other plant part that are above the ground. Monitoring above ground biomass is important for understanding carbon storage, ecosystem productivity, and assessing the impact of land use changes or environmental disturbance. Formula of above ground biomass: weight of stem plus weight of branches plus weight of leaf. Firstly, the formula of stem, for example, arabate. The formula used is 0.313 times bracket dBH, which is 3 times 0.1, because we need to convert in meter. Then close the bracket, power of 2 times bracket 0.054626, which is 8 in meter, times 0 times 10, close bracket, and power of 0.9733. Next is formula weight of branch is 0.136 bracket 0.01668, which is weight of stem that we calculated earlier, power of 1.070. So we will get 0.0169 kilogram. Same as weight of stem, the unit for the weight of branch also should be in kilogram. Finally, the formula weight of leaf is bracket 1.25 times 0.124, close bracket and open bracket, weight of stem, which is 0.01668, power of 0.794. Divide 0.124 and open bracket 0.01668, close bracket and open bracket 0.794 plus 125. Now to get biomass, we need to sum up all of it, and we will get 3.14 biomass for arabate after rounding it. To get the amount of biomass in metric tons per hectare, just take the total of biomass, which is 3.14, divide 0.04, and we will get the answer. That's all from me. Thank you, moderator.
Okay, thanks, Shahir and Izzat, about that. And then I would like to invite Bava to share about the plot graph of reverse Jacob.
Okay, thank you, moderator, for giving me this opportunity to explain about reverse Jacob. So in a forest, if we look at how many trees there are based on their size, we might notice something interesting. So imagine a shape like the letter J, and then but it is flipped upside down, and then in this forest, there are more small trees than big ones. So the upside down J is a sign that the forest is doing well. It means there's a lot of young trees growing, showing that the forest is actively renewing itself. This kind of pattern is called reverse Jacob. Having many small trees is a good for the forest. It means the forest is strong and can store a lot of carbon, which is important for helping the environment. The presence of young trees shows that the forest is continuously growing and renewing itself, playing a crucial role in fighting climate change. So when we see this reverse J curve in this data analysis, it's like a story of a healthy and a sustainable environment for forests, and the forest becomes a protector of nature, filled with variety of biodiversity and a powerful force in the effort to combat climate change. So the forest is like a lively growing community with a lot of young trees and a good balance of nature based on the reverse Jacob we plot. Thank you. That's all from me.
Thanks, Mama, for the great and amazing information about the reverse Jacobs. So next, I would like to invite Nurfa and Afika that will share about the Shannon and Simpson Diversity Index. Yeah, this floor is yours.
Okay, thank you to Ronald Ronley as a moderator. To calculate the data, we use Shannon Diversity Index. Why we use Shannon Diversity Index is because it's popular metric used in ecology to know species diversity, which means the index takes into account the number of species living in a habitat, richness, and their relative abundance, evenness. Refer for formula. H is the species diversity index, and S is the number of species, and Pi is the proportion of individual of each belonging to the each species of the total number of individuals. Okay, so based on our data analysis through random sampling sample, we got 96 different tree species, and for the overall total of species is 947, and we got the Shannon Diversity Index is 3.86349. I will pass for the next person, Nur Afika Amira, to explain the Simpson diversity.
Alright. For Simpson Diversity Index, the meaning of Simpson Diversity Index is a way to measure the diversity of species in a community. The importance of Simpson Diversity Index is to quantify the biodiversity of a habitat. Refer a formula. D is about explain about Simpson Diversity Index. Small n explain about number of individual particular species, and big N is explain about total number of individual of all species. So the Simpson Diversity Index is 0.96251871. That's all for me. Thank you.
Thanks, Nurfatiha and Nurafika for that. And then I want to invite Fikri to share the suggestion for the condition of the area based on the result. Okay, Fikri?
Thank you to moderator. Based on the result Jacob graph, the majority of tree trunk diameter measurement in the area range from 11 to 21 inch can explain good growth and also a healthy tree. Based on the result that have been made, the height number of Simpson reached 0.96, indicating a forest condition with high diversity. In addition, it is likely that this area has fertile soil and sufficient nutrient availability, which contribute to this high amount of biomass. That's all from me.
Thanks, Fikri, for that. And then this time I would like to invite Fahmi because just I heard from another that Muhammad Fahmi is from University Malaysia Kelantan that currently taking SEN, right, which is the Natural Research Science. So I want to ask Fahmi about that. As SEN student, in your opinion, can you justify the conservation effort that you can suggest to enrich the area to be a health ecosystem? Okay, Fahmi, can you answer that?
Okay, thank you for Ronald as a moderator. Okay, I as a student SCN, okay, in my opinion, for conservation efforts, first of all, protecting endangered species and their habitat. This involves preserving natural habitat and ensuring the survival of endangered species, which are crucial for maintaining the balance of nature and supporting biodiversity. Next, promoting sustainable agriculture. Sustainable agriculture practice can help maintain the health of ecosystem and support biodiversity. This includes using organic farming methods, reducing the use of pesticide and fertilizer, and promoting crop diversity. Okay, next, green infrastructure. Green infrastructure, developing green infrastructure such as park, green space, and urban gardens can help improve air quality, provide habitat for wildlife, and promote mental health and well-being for ecosystem. And last but not least, ecosystem service. Ensuring the provision of ecosystem service such as water purification, erosion and flood control, and carbon storage can help maintain the health and resilience of ecosystem. That's all for me. Thank you.
Thanks, Ahmi, for the great opinion for the conservation effort. So thanks to all panel for today. I hope what we get today we can apply in our daily life. That's all. Thank you.